This is the Professor, CBMD PhD, and today's Friday, July 31st, 2026. It is 5:58 and 18 seconds, p.m. Eastern Standard Time, and today's research, black holes. So let's hop to it here. Black holes may spit out nearly as much matter as they swallow. Black holes may be less like bottomless pits and more like cosmic digestive systems that swallow, process, and spit matter back into space. Date July 31st, 2026. Source: University of Warwick. The black hole observed during a dramatic 2023 eruption did not simply devour gas from its nearby companion star. It also expelled large amounts of material through powerful jets and winds, even after the outburst had nearly faded. The results suggest black holes may continue reshaping their surroundings long after their brightest fireworks end. As the black hole pulled gas from a nearby star, it also sent some of that material back into space through powerful jets and winds. The researchers found that these large outflows can continue even when the black hole becomes extremely faint and its activity falls to levels much lower than scientists previously expected. The results suggest that black holes may not behave like bottomless pits. Instead, they may act more like powerful cosmic digestive systems that take in matter, process it, and eject a surprising portion back into space. People often imagine black holes simply swallowing everything around them. What we are seeing is a much more complex process. Matter falls in, the system processes it, and a surprising amount is expelled again. The research produced one of the most detailed optical records ever assembled of a black hole outburst. Rather than capturing only a few isolated moments, astronomers were able to follow the system as it moved through several different stages of activity. Swift J1727.8-1613 was discovered after it suddenly erupted in 2023 and quickly became one of the brightest X-ray sources in the sky. The system contains a black hole drawing gas away from a nearby star, forming a rapidly spinning disk of superheated material around it. Because the outburst was observed in such detail, astronomers were able to watch the feeding process evolve in real time. Events like this have rarely been monitored with such high quality across so many stages. One of the most striking discoveries came when the black hole launched a powerful jet. At the same time, the disk supplying material to the black hole underwent major changes. This gave researchers an unusually clear look at the relationship between matter moving inward toward a black hole and matter being thrown outward into space. The biggest surprise appeared after the black hole's feeding frenzy had mostly died down. Even when Swift J1727 had dimmed to roughly 1/100th of its peak activity, astronomers still detected dense gas being blown away from the system. This finding indicates that black holes may continue producing strong outflows long after their brightest phase has ended. The amount of material expelled could even be comparable to the amount that the black hole eventually consumes. Reflecting on the digestive process of black holes, if black holes can continue shedding material even after their largest outburst, it means they may be much less efficient eaters than we previously assumed. A significant fraction of the meal may never reach the black hole at all, changing our understanding of how binary stars and galaxies evolve. The observations add to growing evidence that black holes do more than consume matter. They are active systems that can redistribute material throughout their surroundings by drawing gas inward and then returning a substantial portion through jets and winds. The astronomers and scientific investigators usually gravitate towards the dramatic fireworks when the black hole outburst begins, but their observations show that the final can be just as intense. Even as the system's X-ray emission dropped to a fraction of its peak, it still had enough power to generate a massive expulsion of gas. By following Swift J1727.8-1613 through an entire outburst, astronomers were able to observe nearly the full cycle of feeding, transformation, and expulsion. The result provides one of the clearest views of how the black holes consume matter, respond to changing conditions, and shape the space around them. And this videography was created for educational purposes only. My code name is Will. I'm Professor Christopher Brunet, leader of research scientist, ufologist, psychic, computer technician, computer programmer, philanthropist, writer, mathematician, artist, photographer, film producer, chef, animal, and nature lover. My passion is world peace. Have a great day. This is the Professor, CBMD, PhD, and today's Friday, July 31st, 2020.